7 hours. That's how long the signal lasted. Not a millisecond burst, not a quick flash. 7 continuous hours. When astronomers first detected it, the question wasn't, what is it? It was something far more unsettling. What could possibly broadcast from deep space for that long? Because here's the thing, the universe isn't supposed to do that. And when scientists finally worked out what it was, the answer was somehow even stranger than aliens. The signal was detected by powerful radio telescopes scanning the sky. Instruments similar to Australia's CSIRO arrays and South Africa's Square Kilometre Array Observatory precursors. These observatories constantly monitor radio frequencies from space, hunting pulsars, mapping galaxies, and yes, quietly listening for anomalies. Most cosmic radio bursts behave predictably. Pulsars? Millisecond pulses. Fast radio bursts? Fractions of a second. Magnetars? Violent but brief. This one, it pulsed, then faded, then returned. For 7 hours, at first glance, it looked artificial, rhythmic, repeating, structured. And whenever something looks structured in space, human imagination fills in the blanks. Was this intelligent? But before anyone could jump to conclusions, the data had to be verified. Because extraordinary signals demand extraordinary scrutiny. And what astronomers discovered next made the mystery even deeper. Researchers traced the source to a distant region within our galaxy. Not another galaxy, not billions of light years away. This was relatively close, cosmically speaking, and here's where it gets strange. The signal repeated every 18 minutes, exactly, like clockwork. Now, in astrophysics, periodicity usually means rotation. Something spinning, but nothing known spins slowly and emits powerful radio waves for that long, unless it's a pulsar. And pulsars spin fast, really fast, milliseconds to seconds, not 18 minutes, which forced astronomers to consider a more extreme possibility, a highly magnetized neutron star, a magnetar, similar to the kind observed by NASA missions studying exotic stellar remnants, like those documented by NASA and the European Space Agency. But magnetars also don't behave like this. At least, they weren't supposed to. So what were scientists actually looking at? A new kind of stellar object? A glitch in physics? Or something that rewrites what we understand about how stars die? The deeper researchers analyzed the signal's polarization, intensity variations, and spectral properties. The clearer it became. This wasn't artificial. It wasn't alien. But it was breaking the rules. And breaking the rules in astrophysics usually means one thing. We've misunderstood something fundamental. After months of modeling and cross-checking archival data, astronomers identified the source, a long-period radio transient. Likely an ultra-slow rotating magnetar. That alone is extraordinary. Magnetars are already among the most extreme objects in the universe. Magnetic fields trillions of times stronger than Earth's. Densities so high a teaspoon would weigh billions of tons. Energy outputs capable of frying satellites from thousands of light years away. And yet, this one spins once every 18 minutes, far slower than models predicted possible for radio emission. For decades, astrophysics assumed such slow rotators would be radio dead, silent, invisible. But this object was screaming into the cosmos for 7 hours straight, which raises a chilling thought. How many more of these objects are out there, undetected? Here's where this story becomes bigger than one signal. This discovery suggests our galaxy may be filled with hidden objects we simply didn't know how to look for. For years, telescopes filtered out slow signals, assuming they were interference. What if we've been ignoring entire categories of cosmic phenomena? Think about that. The universe may not be quiet. We may have just been listening incorrectly. And this is where technology and even AI enters the story. Modern radio surveys rely heavily on machine learning systems to sift through petabytes of data. Algorithms now detect patterns humans would miss. If this signal had appeared 20 years ago, it might have been dismissed as noise. Instead, advanced detection pipelines flagged it as something worth investigating. Which means this might not be the last strange signal we decode. It might be the first of many. 7 hours. A cosmic lighthouse rotating every 18 minutes. A magnetar that shouldn't exist, at least not according to old models. And here's the unsettling part. The universe didn't suddenly become strange. It always was. We're just now developing the tools to see it. So the next time astronomers detect a signal that doesn't make sense, will it be another hidden type of star? A phenomenon we haven't theorized yet? Or something that truly forces us to confront the possibility that we are not alone? Because the more carefully we listen to the cosmos, the more it whispers back. And sometimes it speaks for 7 straight hours.